Elixir School. Basics. Getting started. Basic data types and basic operations. Installation instructions for each OS can be found on elixirlang.org in the Installing Elixir guide. After Elixir is installed, you can easily confirm the installed version with Elixir-V. Try interactive mode. Elixir comes with IEX, an interactive shell that allows us to evaluate Elixir expressions as we go. To get started, let's run IEX. Let's go ahead and give it a try by typing a few simple expressions. Don't worry if you don't understand every expression yet, but we hope you get the idea. Basic data types. Integers. Binary, octal, and hexadecimal numbers come built in. Support for those comes built in. Floats. In Elixir, floating point numbers require a decimal after at least one digit. They have 64 64-bit double precision, and support E for exponent values. Booleans. Elixir supports true and false as booleans. Everything is truthy except for false and nil. Atoms. An atom is a constant whose name is its value. If you're familiar with Ruby, these are synonymous with symbols. The booleans true and false are also atoms, true and false respectively. Names of modules in Elixir are also atoms. myapp.mymodule is a valid atom, even if no such module has been declared yet. Is atom true? Atoms are also used to reference modules from Erlang libraries, including built-in ones. Crypto, strong rand bytes 3. Strings in Elixir are UTF-8 encoded and wrapped in double quotes. Strings support line breaks and escape sequences. Elixir also includes more complex data types. We'll learn more about these when we learn about collections and functions. Elixir supports the basic operators plus, minus, times, and divide, as you would expect. It's important to remember that divide will always return a float. If you need integer division or division with remainder, modulo, Elixir comes with two helpful functions to achieve this, div and rem. Boolean. Elixir provides the or and not operators. These support any types. Negative true or negative 20 or true. There are three additional arguments whose first argument must be, there's three additional operators whose first argument must be a Boolean true or false. And or not. Note, Elixir's and or actually map to and also and or else in Erlang. Comparison. Elixir comes with all the comparison operators we're used to. Double equality, not equality, triple equality, not triple equality, less than or equal, greater than or equal, less than and greater than. For strict comparison of integers and floats, use the triple equal. An important feature of Elixir is that any two types can be compared. This is particularly useful in sorting. We don't need to memorize the sort order, but it is important to be aware of it. Well, this can lead to some interesting yet valid comparisons you may not find in other languages. Number is less than atom, is less than reference, is less than function, is less than port, is less than PID, is less than tuple, is less than map, is less than list, is less than bit string. String interpolation. If you've used Ruby, string interpolation in Elixir will look familiar. Got the pound curly brace. String concatenation. String concatenation uses the less than, greater than operator. Collections. Lists, tuples, keyword lists, and maps. Lists. Lists are simple collections of values which may include multiple types. Lists may also include non-unique values. Elixir implements list collections as linked lists. This means that accessing the list length is an operation that will run in linear time. For this reason, it is typically faster to prepend rather than append. To prepend rather than append. Prepending, fast. Appending, slow. List concatenation uses the with two operands operator. A side note about the name ++/2 format used above. In Elixir and Erlang, upon which Elixir is built, a function or operator name has two components: the name you give it, here ++, and its arity. Arity is a core part of speaking about Elixir and Erlang code. It is the number of arguments a given function takes, 2 in this case. Arity and the given name are combined with a slash. We'll talk more about this later. This knowledge will help you understand the notation for now. List subtraction. Support for subtraction is provided by the ---- operator. It's safe to subtract a missing value. Be mindful of duplicate values. For every element on the right, the first occurrence of it gets removed from the left. List subtraction uses strict comparison to match the values. Head/tail. When using lists, it is common to work with a list's head and tail. The head is the list's first element, while the tail is a list containing the remaining elements. Elixir provides two helpful functions, HD and TL, for working with these parts. In addition to the aforementioned functions, you can use pattern matching and the cons operator, pipe, to split a list into head and tail. We'll learn more about this pattern in later lessons. Tuples. Tuples are similar to lists, but are stored contiguously in memory. This makes accessing their length fast, but modification expensive. The new tuple must be copied entirely into to memory. Tuples are defined with curly braces. It is common for tuples to be used as a mechanism to return additional information from functions. The usefulness of this will be more apparent when we get into pattern matching. Keyword lists. Keyword lists and maps are the associative collections of Elixir. In Elixir, a keyword list is a special list of two-element tuples whose first element is an atom. They share performance with lists. The three characteristics of keyword lists highlight their importance. Keywords are atoms, keys are ordered, keys may not be unique. For these reasons, keyword lists are most commonly used to pass options to functions. Maps. In Elixir, maps are the go-to key value store. Unlike keyword lists, they allow keys of any type and are unordered. You can define a map with the percent curly brackets syntax. As of Elixir 1.2, variables are allowed as map keys. If a duplicate is added to a map, it will replace the former value. As we can see from the output above, there is a special syntax for maps containing only atom keys. The hash rocket versus this. Well, another interesting property of maps is that they provide their own syntax for updates. The cons operator. Enum, a set of algorithms for enumerating over enumerables. Enum. The Enum module includes over 70 functions for working with enumerables, all the collections that we learned about in the previous lesson, with the exception of tuples, are enumerables. This lesson will cover a subset of the available functions. However, we can actually examine them ourselves. Let's do a little experiment in IEX. It's a rather verbose listing of what in Ruby would be dot methods. No? Well, I have no idea what you're talking about, alright? Okay. Oh man, seeing all up in my business. Alright, didn't happen. Oh man. Let's go. Using this, it's clear that we have a vast amount of functionality, and that is for a clear reason. Enumeration is at the core of functional programming and is an incredibly useful thing. By leveraging it combined with other perks of Elixir, such as documentation being a first-class citizen, as we just saw, it can be incredibly empowering to the developer as well. For a full list of functions, visit the official Enum docs. For lazy enumeration, use the stream module. All. When using all to and much of Enum, we supply a function to apply to our collection's items. In the case of all to, the entire collection must evaluate to true, or otherwise false will be returned. Huh? What did I break? Any. Unlike the above, any will return true if at least one item evaluates to true. Chunk every. If you need to break your collection into small groups, chunk every is the function you're probably looking for. Chunk by. There are a few options to chunk every, but we won't go into them. Step is optional, and if not, pass defaults to count. Chunks do not overlap. leftover. Chunk by. If we need to group our collection based on something other than size, we can use chunk by -2 or chunk by /2 function. It takes a given enumerable and a function, and when the return on the function changes a new group, and when the return on that function changes, a new group is started and begins the creation of the next. Changes, comma. A new group is started and begins the creation of the next. It's gotta be some kind of this, right? This thing. Hmm? Really? I do this? Is there some sort of... Wow. Oh, right. Okay. Cool. Map every. Sometimes chunking out a collection isn't enough for exactly what we may need. If this is the case, map every /3 can be very useful to hit every nth items, always hitting the first one. Each. The each function does return the atom OK. To apply map, to apply our function to each item and produce a new collection, use the map function. Get a little bit better typing posture. Oh no. I don't know. I don't know what's happening. Well, don't know. Maybe it's the downloading thing. Well, what can you do? Alright, let's go to map. To apply our function to each item and produce a new collection look to the map function. This is the syntax for the shorthand. So this is equivalent to in Ruby. Do they have the positional thing in Ruby? I mean, what? Oh, right. That's what you get for trying to do Ruby in IEX. Well, all right. Well, oh well. All right. Let's get back to all right, min. Then we have a min by, or, well, min 2, I guess. Filter. The filter /2 function enables us to filter the collection to include only those elements that evaluate to true using the provided function. Reduce. With reduce /3, we can distill our collection down into a single value. To do this, we supply an optional accumulator, 10 in our example, to be passed into our function. If no accumulator is provided, the first element in the enumerable is used. Oh. Sort. Sorting our collections is made easy with not one, but two sorting functions. Sort. Sort/1 uses Erlang's term ordering to determine the sorted order. Sort2 allows us to provide a sorting function of our own. Unique by to remove duplicates of our enumerables. It's kind of surprising when this feels like it should be a sort by. Those common. What's great about Ruby is oftentimes you're not even looking up duplication or documentation because you fall into the method names. And it feels like Elixir, wants to be very ergonomic. I don't know. Pattern matching. Pattern matching is a powerful part of Elixir. It allows us to match simple values, data structures, and even functions. In this lesson, we will begin to see how pattern matching is used. Match operator. Are you ready for a curveball? In Elixir, the equal operator is actually a match operator, comparable to the equals sign in algebra. Writing it turns the whole expression into an equation and makes Elixir match the values on the left hand with the values on the right hand. If the match succeeds, it returns the value of the equation. Otherwise, it throws an error. Let's take a look. Now let's try some simple matching. Let's try that with some collections we know. Oh, they're talking about the piping game. That'd be a nice game, a matching. We had to make it damp. Yeah, Elixir matching speed run through the puzzles that you would make. I don't know, waterfall or something. That. All right. Let's do. Oh no. Okay. Tails should now be 2 and 3. Oh, and maybe the platforms rotate, right? Hmm. So what's my internet? Yeah. What's going on here? Masonry. Isotope. Yeah. Is this, I mean, is it dying? What's going on here? You know what I'm saying? Like patterns of Elixir. We're just playing Vim adventures. Right? This was fun. Oh, I don't have the. you know? I don't know. You know, but yeah, was having similar thoughts about learning Elixir. Could even be pouring little elixirs. That may be too much. I do like the liquid. I don't know. Reminds me of that Pipes, that old Windows game, you know? Yeah. Yeah. But could actually make it the pipe game. Well, I mean, not quite right, but having this go places on each side of the tile would be like the match operator, right? And we trying to get somewhere. And this creates a sense of urgency. Always to the left, though. What?